Hello, in this presentation I will explain heat treatment of metals. The heat treatment is a process of heating and cooling operations applied on the metals as well as alloys in order to obtain the desired properties. Properties like ductility, like electrical conductivity, magnetic property, and all, like strength also. So, to increase these mechanical properties, we can apply the process of heat treatment. This process is done on a definite temperature, and holding time is different for different processes, and the type of cooling which we can apply, like air cooling, air quenching, oil quenching, etc. So on these three parameters, that is temperature, holding time, and type of cooling, the heat treatment is defined many of the sub processes which we can study later. At the starting, heat treatment is defined as the combination of controlled heating and cooling, not only the nature and distribution of micro constituents but also the grain size. It means it is also the process of refinement of grain size. The main purpose and objectives of heat treatment are, as we can as we say earlier, to improve the mechanical properties like machinability, like to soften the material, to decrease hardness, to increase ductility and toughness by doing tempering, uh, to increase strength and hardness, to improve wear resistance, to relieve internal stresses. These stresses which are induced during the cold working process. So it is essential to remove all these type of faults, or you can say stresses which can induced in cold working. So by doing this heat treatment process, we can remove all such type of defects, and also modify the physical properties as well as electrical conductivity, magnetic property, and resistance property, etc. The main heat treatment processes involved, the very first one is annealing, then normalizing, hardening, tempering, then case hardening, which is further subdivided into carburizing, nitriding, sineiding, flame hardening, and induction hardening. These processes are mainly based on the temperature range, the time of holding, and the cooling method. So these are three parameters having an importance when we have study this heat treatment processes. The first one is annealing. In this, the temperature varies from 750 to 950 degrees centigrade, and holding at this temperature, and then slow cooling. Slow cooling means there is no use of furnace or no use of any type of blower. Only we can use the natural air for this cooling purpose, and by this we can refine the grain size, we can improve the structure, we can relieve the internal stresses as well as some faults, some machining properties we can increase to improve the ductility, to reduce the gases contained in steel. So it is the first process of heat treatment. The second one is normalizing, in which we can heat up the steel from 30 to 50 degrees centigrade above its critical temperature and hold for 15 minutes, about 15 minutes, and then allowed to cool down in still air. Means here the time of holding is restricted up to 15 minutes. Fine. But all uh, but remaining parameters are same, like temperature range 30 to 50 degree above means near about 750 to 950 degree, and then it allowed to cool down in still air, means again it is done by the slow cooling method. So by this normalizing we can improve machinability, tensile strength and structure of weld, and also remove the cold work stresses and dislocations due to hot working. The next one is tempering. Tempering is the process which we can use only martinistic steel at temperature below the eutectoid transformation, or we can say that the temperature range up to 400 degrees centigrade, and then holding for the metal for some considerable time, and then is subjected to slow cooling. So it is very much same with the annealing process. The next is case hardening. Case hardening is mainly done to make the steel very hard and resistant and wear resistant, but the core remains soft and tough. The various procedures involved in this are carburizing, nitriding, sineiding, flame hardening, and induction hardening. Carburizing is mainly the addition of carbon, nitriding is the addition of nitrogen, and sineiding, as its name suggests, it is the addition both nitrogen and carbon. And the last two methods, that is flame hardening and induction hardening, is mainly based on the uh, type of flame and type of induction, and the carbon content must be more than 0.3% in these two types of case hardening processes. The nitriding process, in which the pure ammonia decomposes to yield nitrogen which enters the steel. So the temperature range of nitriding is about 500 to 590 degrees centigrade, and this is a process of case hardening of alloy steel in an atmosphere consisting a mixture in a suitable properties of ammonia gas and dissolved ammonia gas at about 500 to 590 degrees centigrade, and it is mainly used for aircraft engine parts such as cams, steam valves, shafts and piston rods, etc. And no phase change occurs after nitriding. This is the limitation of nitriding. Next one is sineiding. Sineiding is done in liquid bath of NaCN, that is cases that contain both carbon and nitrogen, produced in a liquid salt bath at about 760 to 870 degree centigrade, is called simply sineiding. This process is less time consuming because of high heat transfer coefficient in liquid bath and uniform bath temperature. Distortion of pieces is less, and this process takes the time of 1 to 3 hours to produce a case depth of near about 0.25 mm or less. Next one is flame hardening. Flame hardening is mainly used in selected areas of the surface. The temperature range is again similar to annealing, that is 750 to 950 degrees centigrade, and then quenched to form hard structure. Means here for cooling purpose we can dip the metal in a medium differ from air, means whether the medium is water or oil, but not in air quenching. And this process consists of moving an oxyacetylene flame over a part followed by a spray quenching, and the rate at which the flame is moved over the part will be determine the depth to which the part is being heated. Fine. And heating should be done rapidly by the torch and the surface quenched. The last one is induction hardening. The heat is quickly developed by high frequency eddy currents and hysteresis currents on the localized surface of layers. The primary current is carried by a cooled water tube and the workpiece serve as a secondary circuit. Here the depth of penetration decreases as the frequency of current increases. The typical parts that have been induction hardened are mainly piston rods, pump shafts, spur gears and cams, and immediately after heating water jets are activated to quench the surface. So this is all about the heat treatment processes.